Hello everyone, this is the part 3 of Unit 5. In this video, we will study about different approaches of fault tolerance, failure masking by redundancy, fault tolerance by using active replication, fault tolerance by using primary backup, and failover system and its type. Here are the different approaches of fault tolerance. They are max failure. Systems continue to provide its specific function in the presence of failure. For example, voting protocols. Well-defined failure behavior. System shows a well-defined behavior in the presence of failure. It may or it may not perform its specific function but facilitates action suitable to the fault recovery. For example, commit protocols. Redundancy. Replicating critical components or data in a system. For example, multiple copy of hardware, process, data, and so on. Replication. Replication is the process of creating and maintaining the copies of data, object, or processes on a several nodes. Therefore, if failure on one node occur, then data will be accessed to the user from other node. Checkpointing. Saving the state of the system when they are in consistent state and storing it on a stable storage. Each such instant when a system is in stable state is called checkpoint. In the case of failure, system is restored to its previous consistent state. Failure masking by redundancy. Redundancy is a key for hiding the failures. Failure masking by redundancy is a fault tolerance technique that involves redundancy in a system to mask or hide the effect of failure. The basic idea is to duplicate the critical component or data, allowing the redundant elements to take over in the event of failure. Thereby, it maintains the system functionality. The goal of failure masking by redundancy is to provide a reliable systems that can gracefully handle the failure without causing the noticeable disruption to the user. Types of redundancy. Information redundancy and extra bits are added to allow the recovery from the garbage bit, such as error correction code in message, for example, use of Hamming code. Time redundancy, an action is performed and then if needed it performed again until the transaction is succeed. For example, transaction. Physical redundancy, extra equipment is added, that is software and hardware. For example, process replication, electronic circuit, and so on. Fault tolerance using active replication. Each device is replicated 3 times. Here, botter is replicated 3 times. Each stage in a circuit is a triplicated botters. These are the botters and they are triplicated over the systems. Each botter in the circuit has 3 inputs and 1 outputs. This botter have 3 inputs and 1 outputs. All the botters have same. If 2 or 3 of the inputs are same, the output is equal to that input. If all the 3 inputs are different, the output is also undefined. This kind of design is known as TMR, triple modular redundancy. Suppose if A2 fails, then each of the botters B1, B2, B3 gets 2 inputs and 1 rough inputs, and each of them outputs the correct value to the second stage. यदि A2 चाहिँ फेल भयो भने B1, B2, B3 ले दुईटा चाहिँ इनपुट करेक्ट पाउँछ, एउटा चाहिँ रफ पाउँछ. दुई भन्दा बढी इनपुट चाहिँ करेक्ट पायो भने आउटपुट पनि के आउँछ, करेक्टै आउँछ. The effect of A2 failing is completely masked. The effect of A2 failing is completely hidden in the system so that the input to B1, B2 and B3 are exactly the same as they would have been had a no fault occur. If B3 and C1 are also faulty in addition to A2, then these effects are also masked, so the 3 finals outputs are still correct. If B3 and C1 also fall in addition to A2, then these are also completely masked. The 3 finals output are still correct. This is the fault tolerance by using active replication. Now, fault tolerance using primary backup. This is the simple primary backup protocol on write operation. Here, if this primary crashes before doing the step 2, that is before doing the work, then no harm is done in the system. After doing the work but before sending the update, if this primary will fails after doing the work but could not update, then primary backup will work second time. If primary crashes after step 4 before step 6, if it crashes after step 4 and before step 6, then work may end up being done 3 times, once by the primary, once by the backup as the result of step 3, and once after the backup become primary. With a primary backup approach, one server, that is this primary, does all the work. When the server fails, the backup take over. When this primary fails, then the backup will take the function of primary. A backup may periodically ping the message that are you alive? If it fails to get an acknowledgement, then the backup will assume that the primary fails and it will take the function of primary. This backup will ask for the primary that are you alive? If backup doesn't get the acknowledgement from the primary, then it assumes that primary fails and the function of primary will be taken by the backup. Now, failover system. The failover system mechanism is used to increase the reliability and ability of IT resources. Failover systems are commonly used for the mission critical program such as disaster recovery like earthquake, fire, flood, etc. and reusable service that can introduce a single point of failures for the multiple application. There are three different types of failover systems. They are cold failover, hot, and warm. In a cold failover, the backup system remains inactive until needed. It starts from the state of minimal or no activity and is brought online only when the primary system fails. Typically, cold failover solutions have longer setup time compared to warm or hot failover, as they may involve initializing the hardware, loading the configuration, and starting the service from the scratch. Now, we'll see about warm failover and hot failover. A warm failover system is partially active and prepared to take over the operation in the case of failure. Unlike cold failover, some components or service are running, reducing the time required to switch to the backup system. While not fully serving the workload, a warm failover system has certain components or service in a standby mode. This helps in achieving a faster transition compared to the cold failover, as some resources are already initialized. Hot failover. In a hot failover, the backup system is fully operational and actively handling the part or all of the workload concurrently with the primary system. The hot failover system is continuously synchronized with the primary systems, ensuring that it can take over easily without any noticeable interruption in a service. This approach provides the quickest recovery time compared to cold and warm failover system. These are the different type of failover systems. Now in next video we will study about agreement in faulty systems and multicasting.
Thank you for watching till now. If you are new, then please share and subscribe the channel so that it can be reached out to many people. Thank you.